One of the things, we're going to do function operations. It's where we're going to combine functions. So I just want to do a quick little review. It's not in the notes, but remember, if we wanted to say something was a function, we could use something like this. That means the function f with a variable x. So it's the same thing as like saying y is equal to x squared, whatever. We're just saying that it's a function. That's what the f means, and we could use any letter we want, but the little parentheses around the x just means that x is the variable. So if I wanted to say I wanted to actually put some value in for x, you could write it like this. Okay, so what that means is then I would put a value of 2 into the x. So this part doesn't enter into the equation. It just tells me what I have and what I want to do with the equation. It's not like where we're evaluating, where it's actually entering into the equation. Okay? Now, what we're going to do today, we're going to have some things that are going to limit the domain. We can't put certain values of x or whatever the variable is. Obviously, I could have written something like this, f of a. That means, I've got a instead of x. That's all that means. So whatever variable it has, that's what I need in parentheses. Now, what we have is when we combine these functions, we can get two cases that are going to create us that we cannot put certain values in there. An example would be as if I have a square root or a fourth root. You cannot have a negative number underneath the root sign, right? If it's an even root. So we would have to put a domain limitation on that. We would have to say, okay, x is greater than or equal to 0 in that case. Again, in this case, x is greater than or equal to 0. So you can't have anything that creates a negative root for a square root or a fourth root. So if you had something like this, what you have, you're going to have to say, what values of x can I not use? Well, you know that what's ever inside the square root has to be greater than or equal to 0, because you can't have a negative. You can just set up a little equation to figure that out. So x minus 5 has to be greater than or equal to 0. X must be greater than or equal to 5. And sure enough, if you look at the square root, you could see that I can't put a 4 in there. 4 minus 5 would be a negative 1. No negative square roots. So this just tells me what the domain will be. The only values I could use in there would be values of x that are greater than or equal to 5. That's one of the limitations I have when I have square or fourth roots. The other one is when I'm dividing by my variable. So say, for example, I would have 5 over x. You cannot divide by 0, so if my variable is in the denominator, I also have to figure out what value I can't use. Well, this would be all real numbers except x equal to 0. Right? Another way to write that is I could just say x cannot be equal to 0. If I had something like this, 5 all over x minus 3, then I'd have to say, okay, what value wouldn't work in there? X could be any number, but it can't be 3 because 3 would give me 0. So I would have to say all reals except x not equal to 3, right? That would be the value that I couldn't put in there. And so that's what we're going to do. So we're going to have those kind of limitations that we're going to have to deal with. We have to specify the domain. Okay, the first thing I want to go over is just the notation that they're going to use. What they have here is this means take function f that has x as a variable and add it to function g that has x in a variable. That's what that means. And that says, for example, if I would want to evaluate this, let me just do a couple quick ones here on a separate sheet. If I say function f, which has a variable of x, is equal to x plus 2, and I say function g, and it has to have the same variable then, is equal to x minus 5. And I say evaluate f of x plus g of x. And I write it like that. So what you're going to do, I'm going to say let's evaluate f at 2. Okay, so that means evaluate f at 2 and g at 2. So what you do, f evaluated at 2. Okay, here's f. That would be 2 plus 2, that's 4. And g evaluated at 2 would be 2 minus 5, right? 2 minus 5 would be a minus 3. 4 plus a minus 3, that'd be a negative 1. Okay, so I'm taking and I'm putting some value into f, evaluating it, then taking g and adding it to f when g's got the same value. Thank you. So that's one way to do it. But what we're going to do now is we're going to combine the functions first. Okay, so now what the notes are going to say is they're going to write something like this. F plus g of x. What that means is it wants you to combine f with g first. Okay, so you're going to combine the functions first. So you're going to leave x as the variable. So basically what you're going to do is you're saying combine them first. So that would be x plus 2 plus x minus 5. So I'm combining the functions with x first. That would be 2x minus 3. So f plus g would be that. Okay, so what the notes here are saying is they're saying what we want to do is we actually want to combine f and g together while they still, both of them, have the variable x. We want to make the addition with the x's still in there without any values substituted in. We want to subtract them first. We want to multiply them first, or we want to divide them first. That's telling us to combine them before we do and put in any values. That's how we write that. Notice how that differs from the way it's written over here. That tells you to put the values in first, then subtract them. So that's what this kind of notation means. Combine them first. Okay, so let's do one of those. And here are the domain comments again, because one of the things obviously we're going to have to do in some of these when we combine them is do the domain. When we have a division, you can't have a denominator of 0, so we have to figure out what values of x would make the denominator become 0 and exclude that. The next thing that can't happen is we can't have a negative even root. That means a square root or fourth root can't have a negative number underneath there. Okay, so let's do a couple examples, and you have your sheets. Now, actually, there's 3 separate little problems here. And one of them, it just says, okay, combine the 2 functions. The next thing would be then, okay, well then plug 4 in and see what the evaluate to. And the third thing would be state the domain. Okay, so let's do number 1 first. So for number 1, what it's telling me is to combine f and g, add those together. So I'm going to write that. F plus g in parentheses, that means to combine them first. My variable's x. And so what that would be is here's f. So I'm going to say 3 times the square root of x. Then I'm going to add that to g, because that's what it tells me to do, is add it. And g of x is right here, a minus 10 times the square root of x. So if I take 3 times the square root of x plus a negative 10 times the square root of x, remember the 3 plus, minus 10, that would mean a minus 7 times the square root of x. And there's the f and g added together, combine them first. Okay. Next problem would be say, okay, evaluate it when x is equal to 4. So what I'm going to do is I'm going to use the right nomenclature. I'm going to say, okay, here's f plus g, and then I'm going to evaluate it at 4. Now, the 4 is not part of the equation. It's just saying I'm putting 4 into all the x's. Okay, so what that would be is here's a negative 7, and now there's an x. Let's put a 4 in there. So the square root of 4 is 2, so this would be equal to a negative 7 times 2 would be equal to a negative 14. So I evaluated the combination of f plus g at a negative 14. Now then, the last thing it asks me to do is it says state the domain. Okay, so let's look at what I had when I added f and g. That's this piece right here. And we need to look and see what values of x can we not use. Well, I have a square root. cannot have a negative under the square root. So for this one, the values of the domain would be what values can I use? What values can I use? Well, I could use any value of x that's greater than or equal to 0. I couldn't use any negative values. Okay, here's the next problem. The example, it says, I'm going to add f plus g. Now, we got to be careful when we look at this. I don't know that your homework or any of the notes have it, but it could say, now this is not the problem, but it could say this. What that means is take x and add it to itself. So if this was the problem, you would say, okay, I'm taking f plus f. That would be 5 times the square root of x plus f again. 5 times the square root of x is 10 times the square root of x. So it doesn't always have to say f plus g. It could say f plus f, you know, something like that. It has to give us the values of the functions, though. So in this case, we have, it's given us function f, and it's given us function g. And what this particular question says, it says, okay, add those together, combine those first. So we would say, all right, we're going to take f and add g to it with the variable x. So that would be 5 times the square root of x minus 8 times the square root of x. That's a negative 3 times the square root of x. So I combined them. Now the next part would say, okay, evaluate them when x is 16. So let's do that and use the right nomenclature. So I'm taking the combination of f and g added together, and I'm going to evaluate that at 16. So I'm putting 16 in for x. So I put it in parentheses. And then I say that would be equal to a negative 3 times the square root of 16. Put 16 into that x. That would be equal to a negative 3 times 4. That'd be a negative 12. And now then I have to figure out, by looking at when I combined them right here, let's see what value of x could I not use, and I can't have x be negative, so my domain is going to be all the values where x isn't negative, so that would be domain is x greater than or equal to 0. Okay, the next example asks us to subtract functions, and it's saying take f, subtract g from it. So f minus g, that's the first step. So f minus g, so I have to be careful here because all g is subtracted. So this is going to be 3x squared. Wait a second, there's a couple of problems here. Let me fix them. I'm going to turn this off. I miswrote the problem. Okay, so I changed the problem. So what I have is I have 3x cubed, and that is a minus sign that's hard to see, minus 2x squared plus 5, so that's f. And it tells me to subtract g, so the entire g function is subtracted. So the whole thing, so that's x cubed minus 3x squared plus 4x minus 2. Okay, so I got to be careful there because I'm going to change the sign on everything. So that's equal to 3x cubed minus 2x squared plus 5. Now this is why it was important to write it like that, because this negative will go into every single term. So this is minus x cubed minus this minus 3x squared. Okay, that's plus 3x squared. Minus the 4x. That'd be minus 4x minus a minus 2. Okay, that's plus 2. Now let's just combine them. I have a 3x cubed and a minus x cubed. That's 2x cubed. Negative 2x squared plus 3x squared. So if I add those together, that's going to be plus x squared. Then I have this minus 4x. Plus 5 plus 2 would be plus 7. Okay, there I have them combined. Next step, it tells me to evaluate it when x is negative 2. So let's put f minus g evaluated at a negative 2. That's how I would write that. Plug a negative 2 in for each value of x. Every single value of x gets that So that would be 2. X cubed would be a negative 2 cubed. Here's an x squared, so we're going to take a negative 2 and square it. There's a minus 4 times a negative 2 plus 7. Negative 2 cubed is a negative 8. Negative 8 times 2 is a negative 16. We have a negative 2 squared. That would be plus 4. I have a negative and times a negative. That would be plus 8. And then I have plus 7. So I have a negative 16 plus 4. Okay, so that's a negative 12. Now I have a negative 12 plus 8. That's a negative 4 plus 7. So that's going to be 3. The last piece is to find the domain. And I don't have any square roots. So that's good. And I don't have any denominators. So there's nothing in there that's going to give any problems. So x is all reals. Okay, the next one is a multiplication problem. And it says to combine f and g by multiplying them together. So the first part is to find f times g. So f is x squared. So f times g, and we're using x as the variable, would be x squared times the square root of x. And that would be the combined. Now I could, if I wanted to, I could change that to 1/2 and then keep it an exponent form, but I think I want to leave it like that. I think it's easier for you to see that if I had to do the domain, I couldn't have a 0 in there, right, or a negative number. I couldn't have a negative number into the square root. So for this one, the domain part, we can see that already. The domain is going to be x has to be greater than or equal to 0 because I can't have a negative square root. Okay, let's do the next part, 2. That would be evaluating it when x is equal to 9. So I'm going to put f multiplied by g, evaluated at 9. That's going to be putting the 9 now into this x, would be 9 squared, times the square root, putting 9 into the other x. That would be equal to 9 squared is 81. The square root of 9 is 3. So that would be 243. And I already did the domain. Okay, let's do a division. Now these are going to be a little bit harder because I already know that if I'm dividing one function by another, I can have an x in the denominator, and then I have to figure out what would make the denominator go to 0. And it gets kind of tricky. So anyway, let's do part 1, which is just combine the two. So what it tells me is I want the function f divided by function g. And so what that would be, and of course the variable is x, is function f is 6x, and dividing it by g would be x to the 3/4. Right, so there's the function before I simplify it. That's going to be important because I still have to look at this to find the domain. I have to look at what it looks like when I combine them, when I do the domain. Now I can simplify it, but that's not really going to tell me all I need to know about the domain. So anyway, let's go ahead and simplify it. So this is really x, 6x, and this would be, well, I guess I'm just repeating myself there. So I can subtract the exponents. So that's going to be 6. The exponent on the x is 1, so that would be x to the 1 minus 3/4. That would be 6x to the 1/4, which if I wanted to write it in radical form, it would be the 4th root of x. So here's an important part about the domain, and we'll evaluate in a second. Let's do the domain now while it's easy to see. So the domain, which I'm going to label as 3, doing the domain, is I already said we got to look at what we had originally. not after it's simplified. If you wanted to look at the domain after it's simplified, you're going to say, okay, I don't have any denominators, so the domain of this would be x greater than or equal to 0. But if you look at what I had when I first combined them, not only do I have a fourth root, so that would be x not equal to 0, so x would have to be greater than or equal to 0. I also have an x in the denominator, which means the x can't equal to 0, because if this x right here was 0, 0 to the 3/4 would give me 0. So that's what's going to specify my domain, and what I can see is it has to be greater than or equal to 0. Oh, but it can't be equal to 0 either, so x, the domain in this case, is x has to be greater than 0, not equal to 0. So this gets kind of tricky. You have to look at when you first combine them right here and see what can't you use, because when you simplify them, you may actually get a slightly different domain. Okay, so anyway, let's go to the second part. And what the second part says is we are going to put 16 in for x. So here's what I'm going to write. I'm going to put f divided by g, evaluated at 16. So that would be 6 times the fourth root of 16. That would be 6 times 2, which would be 12. Okay, the last example of the function operations, it's another division. So I'm going to say this is part 1. We're going to say the domain, and I'll do that third. And the second part is when I'll evaluate, I'll evaluate it at x is 27. So let's go ahead. It says f divided by g. So I'm going to take f and g divided by g, variables x. F is 4x, and g is x to the 2/3. Okay, so let's go ahead and simplify that. That would be 4x to the 1 minus 2/3. That's equal to 4x to the 1/3. Okay. Now I'm going to evaluate that at 27. So f divided by g, evaluated at 27, would be 4 times the cube root. I'm going to go ahead and write it as a cube root here. Would be 4 times the cube root of x, 4 times the cube root of 27, 4 times 3, that's equal to 12. And the last part is to find the domain. Okay, so let's look at this piece right here. Now notice that over here, that would be all real numbers, because a cube root, I could have a negative underneath a cube root. But in when I combine them, now here's a cube root right there. The 3 means cube root. So I could have a negative number, but what I can't have is I can't have x equal to 0, because x is a denominator right there. So my domain is going to be all reals where x is not equal to 0. That would be my domain. I could have any number except x equal to 0.